Okay, so picture this. You're in an intensive care unit. A patient's heart has just been restarted. A huge, incredible medical victory. But then, after all that chaos dies down, this question just hangs in the air. And it isn't just if they're going to survive.
See, that's the real shift, right? It goes from a physical crisis to this agonizing existential one. The emergency part is over, but now everyone, the doctors and especially the families, are left with this one almost unbearable uncertainty. Is the person they know, the person they love, actually going to come back?
And this is where it gets incredibly tough. It's what doctors call mixed prognostic findings, and it's a total nightmare. So, for example, a patient might have some basic reflexes, which, that feels like a hopeful sign, but at the exact same time, their blood pressure's all over the place and they need medications that actually suppress brain function. So one piece of data gives you hope, and the other one just snatches it away. Everything is pulling in opposite directions. Making a clear call, it feels almost impossible.
So, what do you do in the face of all that uncertainty? Well, medicine's answer is to get systematic. You build a map. You can't just rely on one single piece of data when the stakes are this high. The goal is to create this really comprehensive picture of the brain's physical state.
The whole approach has a fancy name, multimodal neuroprognostication. But really, it just rests on these three main pillars. You're gathering evidence from how the brain is functioning, what its physical structure looks like, and what its chemical signatures are telling you. You put it all together to get the clearest possible picture of the damage.
Let's start with function. That's where the EEG comes in. It's basically measuring the brain's electrical symphony in real time. And we're not just looking to see if the brain is, on or off. We are hunting for very specific, very predictive patterns in the brain's circuitry.
And one of the most ominous patterns you can find is something called burst suppression. What you see are these short bursts of electrical activity, but then they're followed by these long, flat periods of almost complete silence. When you see this pattern, especially if it goes on for a while, it's a really powerful sign that the brain circuits are deeply, deeply compromised. It correlates very, very strongly with a poor neurological outcome.
Okay, next up is the brain's physical structure. For that, we turn to CT and MRI scans. These give us an actual map of the geography of the damage. Doctors are on the lookout for key signs like cerebral edema, that's just widespread swelling, or something called restricted diffusion on an MRI. You can think of that as a spotlight just highlighting the areas where cells have died and the damage is irreversible. It's a literal, physical map of the injury. And finally, we have the chemical signature. This is where biomarkers come in. These are proteins that basically leak out into the bloodstream when brain cells die. One of the really key ones they track is called neuron-specific enolase, or NSE. Just think of it as a chemical breadcrumb trail, a measurable proxy for just how much damage has actually occurred.
Now this is where it gets really interesting, because with a biomarker like NSE, timing is absolutely critical. The levels tend to peak somewhere between 48 and 72 hours after the injury. So if you see extremely high levels within that specific window, well, that becomes a very, very strong predictor of a poor outcome. It's the combination of how high the number is and when you measure it that gives this piece of data all its predictive power.
So let's just take a breath for a second. We've got functional data from the EEG, we have structural data from the scans, and we have chemical data from biomarkers. We've built this incredibly rigorous, really impressive map of the physical system. And yet, all of these advanced tools, they all lead us right to the edge of a cliff, to this profound and totally unanswered question.
And this is it. This is the heart of the whole problem. We've done an amazing job of quantifying the physical injury to the brain. But have we quantified the mind? Have we found a way to measure the person? The answer is no. We can measure the brain, but we haven't found a single tool that can measure the mind.
And because we've hit that wall, because science has reached its limit, we have to turn to a pretty surprising source, ancient philosophy. Specifically, the Bhagavad Gita gives us a really profound language for talking about this exact boundary that our modern science just can't cross.
The concept here just maps perfectly onto our clinical problem. First, you have the field, or kshetra. This is the entire material world, the body, the senses, and yes, the brain with all its measurable parts. It's the physical stage where the drama of life unfolds. And then you have the knower, or kshetrajna. This is something different. This is consciousness itself, the subjective experience, the soul, the actor on the stage. It is not the stage itself.
And that right there is the crucial insight. Our best modern technology is incredible at mapping the field,
We can look at the stage and say, yep, it's damaged, but it looks like it could still support a performance. But we have absolutely zero technology, nothing, to predict whether the knower, the actor, will ever actually return to that stage. And realizing that, well, it forces a profound sense of clinical humility.
So what does this mean in the real world? Where do we go from here? We have to take this combined understanding, the hard data about the field, and this deep philosophical insight about the knower, and figure out how to act. How do you move forward when you're faced with such a deep and fundamental uncertainty?
Well, the first thing is you have to avoid this huge danger, this terrifying ethical trap. It's the self-fulfilling prophecy. Think about it. If the early data is confusing and the medical team starts to lean toward a poor prognosis, that bias, even if it's unconscious, can start to subtly change their actions. Maybe they become a little less aggressive with treatment, a little less vigilant.
And then what happens? The poor outcome they expected comes to pass. But it wasn't necessarily guaranteed by the original injury. It was influenced by their own expectations. So given that grave risk and the profound uncertainty we've been talking about, there's really only one responsible way to move forward. And that path is shared decision-making. It has to be, because if we accept that absolute certainty is completely off the table, then this becomes the essential bridge. It's what connects the cold, hard data about the field with the deeply human values that surround the knower. And this just transforms the whole process. Right? It's no longer a doctor just dumping a bunch of statistics on a family. It becomes a real human conversation. The question actually changes. It's not, what does the data say we should do? It's, what risks are we, as a team, including the family, willing to accept for the hope that the knower might return? You have to rely on honesty and compassion to bridge that gap that our science simply cannot.
So what a journey, right? We started in that incredibly intense moment in the ICU. We walked through the most rigorous tools of modern neuroscience, and they took us right to the very edge of what we can measure. And it was that scientific limit that led us to an ancient philosophical truth that, in the end, helps us navigate this impossible space with humility, with honesty, and with compassion. Which leaves us with one final, really provocative question. If our most advanced science can perfectly map the field, the physical brain, but remains totally blind to the knower, the conscious self, then we really have to ask ourselves, should the limitations of our tools ever be allowed to define the limits of our hope?